Hello everyone, welcome to the channel. For this tutorial, I'm going to go over file I/O in Linux or Unix-like system. Now this tutorial is more on the system programming side of Linux. But before I start writing code, I'm just going to go over briefly what is file I/O. Now file I/O stands for file input output. It refers to how a program read data from a file or write data to a file. Now you have the cat command that can display data from a file, and you also have the echo command that can write data or write text to a file. Now it's not best practice to call command lines command in your program, especially if you're using C. Now before a file can be read from or written to, it must be open. The Linux kernel maintain a list of files called the file table, and this is what a file table look like. I don't want to get too in depth with file table because it can get a little bit complex, but just keep in mind this is what a file table look like. Now the file table is indexed by a non-negative integer known as file descriptors, right? So a file descriptor is basically non-integer number like 0, 1, 2, 3 and so forth. Each of the integers have their purpose. So I'm going to use VI to write out this code. So the first thing I want to do is just do a quick ls in my directory, and you can see that there is nothing in there. So let's go ahead and create a file, a .c file or a C file. So I'm going to use the command touch, and I'm going to call my file files.c, and I'm going to hit enter, and if I use ls, you will see my files.c file in there. You can just simply use vi and the name of the file, and that will also create the file for you. Right away, I'm going to give the permission for the files.c. So I'm going to say chmod 755 files.c, right? And this is going to change the permission for the file. Now I'm going to use vi to open the file. So I'm going to say vi files.c. First thing that I want to do is include some header files. So the first header file that I'm going to include is the fcntl.h. So I'm going to say pound include, and inside of anchor brackets, I want fcntl.h, and I'm going to close it. With me personally, I like to leave a little space after the include. So this header file is where you're going to find the system call open. Pound include, and I want to include stdio.h. And this header file is just for the print functions. If you're using printf, scanf, it's always good to add in this header file. And the last one that I'm going to include is unistd. So unistd.h, and this header file is for the POSIX system call for read, write, close, fork, and so forth. And we're going to come back to the header files once we start writing out the code. I'm going to write everything inside of the main function. So I'm going to say int main, my open and closing curly brackets. Inside of main, the first thing that we want to do is open or create a file descriptor. So I'm going to say int, and I'm going to call my file descriptor fd, and I'm going to equal fd to the open system call. Now the open function, it's not a regular function in the C library. It's a system call, a POSIX system call. When I say system call, I mean an action happen when you use this function. So it's going to open the file for reading, or open the file for writing, or stuff like that. And the open function will return, or the open system call will return, a file descriptor. As we said previously, the file descriptor is just a small integer that represents an open file. So the open function can open files, it can open directories, it can open pipes, it can open sockets, it can open FIFOs, devices, and so on. Let's take a look at what goes inside of the open function or the open system call. the first thing you want to do is give the function or the system call a name or a file to work with. And that's usually a pointer. So inside of the open function, we're going to give it a file called hello.txt, right? And this is going to go in our current directory. Then we have to give the file some flags. What do we want to do with this file? So either we want to open the file for reading, open the file for writing, open the file to append stuff to it. That's just what simply the flags mean. So we have the access mode flag. We have the opening behavior flags, which is file creation. And there you can find your create file, you can append, you can truncate. Then you also have performance flag or file status. You also have file descriptor behaviors and temporary or special use flags. So for this part, we just want to open the file for read only. So the flag for that is going to be O_RDONLY. And then we are going to end our line. The next thing that we want to do is have some stipulations. If the file is not there, we have to give some type of messages or error saying the file is not available. So we can say if and fd equals -1. And I'm just going to put my open and closing brackets. This means that if the file is not there, that's going to be -1. So -1 means the program didn't execute it as it should. The file is not available. For this, I'm just going to use this the function PERR, so PError, and inside of PError, I'm just going to use the word open. And after that, I'm just going to say return 1. So PError is a debugging tool, and it will print a message describing the last error. So if the file or directory is not there, it will say open no such file or directory. If we do not have permission to open the file, we're going to get an error saying open : permission denied. So this is just basically what this is doing. This is just a debugging tool. We're going to see how this works when we run this program. So after the return statement, we're going to go down and we're just going to use the write function. So I'm going to say write, and inside of the write function, I want fd, which is my file descriptor, and I'm going to write, let's just say hello world \n. This is for a new line. And then inside of the write function, we also have to give the buffer size. So I'm just going to say 14, because if we count exactly how much characters is here, it's going to be 14. Now, if you're going to write a longer text, then the buffer size would have to be longer. And then after write, you cannot open a file and just leave it open. You also have to close the file. So we can say close, and you have to tell the program which file you want to close. We want to close fd, and then return 0 if the program executed properly. That's it for this small program right now. So let's just go ahead and run this program, and then we can get back into writing more flags. So first, this is going to be the first flag that we're going to see. Read only. We want to open this file for read only. Now this file does not exist in my folder, so we should get back an error saying open no such file or directory. This is what this line of code is going to return to us, or should return to us, right? So I'm going to press escape :WQ to save and quit and get back to the terminal. We are going to use GCC to run this program. So we're going to say GCC-O for our output, and we're going to call this file files. And I want the output from files.c. So this is just going to run this file. The O is the output file, so it's going to create a file for us called files, which is the output file. And then we're going to take the results from files.c. So I'm going to go ahead and hit enter. Now, if I do an ls, I can see now my files is inside of my directory, right? So I'm going to run the output file. So \, which means in my current directory, look for the file called files. And I'm going to hit enter. And right here, it says open no such file or directory. This is exactly the result that we wanted. This open here is from the P error, and it gives us the last error that was inside of the buffer. If I go back to VI, this error is coming from here. So let's delete read only, and let's look at the other flags that we have. We have write only. So I can say O_RWONLY. If I run this, I would still get an error because we did not create this file. And I'm going to rerun the file again, rerun GCC to compile. And if I do an ls, the file is still in there. So I'm going to say /files. And it's here, it says open no such file or directory, because there is nothing in our folder that is hello.txt. So let's go back into VI and give it a different flag. So this time we want to write, and then we also want to create. So I'm going to give a pipe, and I'm going to say O_create. And with the create flag, you must give some type of mod. Now, this is where the program can get a little bit more complicated, and I'm going to make a different video for this section. But for this tutorial, I'm just going to explain it briefly. Now, remember in Linux, you have file permissions, right? Read, write, execute, owner, user, group. Now, you have the octal values for this file. When you write in the program and you inside of the open system call, we use 0 before the octal value. So if we look here, I want the owner to read and write from the file, but the user and group, I just want them to read the file and not write into the file. So I'm going to use this octal 0644. Now, where this can get a little bit complicated is there is something called mode_t, and then you see mode. So it looks something like this, mode_t, and then you have mode, right? So the mode can be, let me see if I can pull it up here. Okay, so here is a list of the mode, right? These are the constant and these are the octal value. Now, when you're using the octal values, we don't need to include the mode header file. If you want to use the constant, you must include the header file. So I say include sys/stat.h. You must include this header file if you want to use the mode_t data type. And that will give you access to the constant instead of using the octal. So for this video, I'm just going to use the octal. So I want to create the file, and when the file is created, I'm going to give it the octal value 0644. Let me just go over it quickly again. I'm doing a system call, and hello.txt is the file that I'm looking for. If it's not there, create the file and give it 0644 permission. This is what this flag is doing. Now, when we create the file, I want you to write hello world in that file in hello.txt. And when you finish writing hello world into hello.txt, I want you to go ahead and close it, then end the program. Okay, let me get out of this by saying escape:\wq to save and quit. And let's go back and run the file again. GCC-O, we run this file. Now, if I do an ls, you see here, we only have the output file, which is files that we got from GCC. And we have a program file, files.c. Now, let's go ahead and run the output file. So I'm going to say ./files, and I'm going to hit enter. Now, everything executed properly. I didn't get back open no such directory. I didn't get back any error. Now, if I go ahead and run the ls command, we can see our hello.txt file is inside our directory. So what we can do is go ahead and display the content of that file. So we can say cat hello.txt, and we should get hello world. Okay. Now let's look at another flag. Let's look at the append flag. So I'm going to go back in VI, and for append, now here, let's just say O underscore APPEND. Okay, so append means that we want to write to the end of the file automatically. We're going to append hello world, but let's change it to hello world 2, so you can see the difference. To change the buffer size to 15, and let's save and quit. Escape :WQ. Let's run the program again. Everything runs successfully. If we do an ls, we still have hello.txt. Now let's go ahead and cat. Oh, we need to run the output file, and then we can go ahead and run the cat command. And here you can see that we have hello world 2. So that's what the append did, right? So when you're doing system programming in Linux, this is the preferred way to read and write from a file. So that's it for this tutorial. Hope you have learned something. If you did, please don't forget to like, subscribe, share, and I will see you guys in the next tutorial.